So this is a video on bases. So our aims for this video are to be able to calculate the pH of an alkali, to calculate the concentration of an alkali if you're given the pH, and also to calculate the pH of water at different temperatures. And you'll find that at different temperatures water's pH is not 7, so you also need to be able to explain why this water is still regarded as being neutral even though the pH is not 7. So before we can work out the pH of an alkali, first we've got to understand a little bit about how water dissociates and how we can use that to our advantage when calculating the pH of an alkali. So the pH of water is generally regarded as being 7, and that's at 25 degrees. Now what that means is that there must be an H plus concentration in water for it to have a pH of 7. And the pH of water being 7 means the concentration of H plus must be 10 to the minus 7. Now water, therefore, dissociates into H plus and OH minus. Now for every water molecule that dissociates there must be one H plus and one OH minus, which means the concentration of H plus equals the concentration of H minus, which equals 1 times 10 to the minus 7, or 10 to the minus 7. That gives us, that means we can work out, give us an expression, and that expression is called Kw, or the ionic product of water. And the ionic product of water is just that, it's the product of the concentrations of the two ions that are found in water, H plus and OH minus. And if we multiply 1 times 10 to the minus 7 by 1 times 10 to the minus 7, it gives us 1 times 10 to the minus 14. Now Kw equals 1 times 10 to the minus 14 at 25 degrees. Because H2O or water is in equilibrium with H plus and OH minus, if we increase or decrease the temperature, then this equilibrium will shift left or right, which means that this Kw value can change depending on the temperature, but they will give you a Kw value if you're not supposed to use 1 times 10 to the minus 14, but you assume that Kw equals 1 times 10 to the minus 14 unless otherwise told. Now, let me just delete that and move this up here. So to calculate the pH of an alkali, what we're given is basically the concentration of OH minus in an alkali. So if we're given the concentration of NaOH, that's going to equal the concentration of OH minus ions. So what we do is basically rearrange this equation to get H plus by itself, because remember that's always what we're trying to strive for when we're calculating a pH. So therefore the concentration of H plus equals Kw, which is generally 1 times 10 to the minus 14, over the concentration of OH minus, and then we put that into our pH expression. So this is the expression that you have got to use in order to calculate the pH of an alkali. So if we put that into practice then, here we've got to calculate the pH of sodium hydroxide. It says at 50 degrees, but it hasn't given us a Kw value, so we're going to assume it's 1 times 10 to the minus 14, and it's got a concentration of 0.140. So what we're going to do is use Kw, so Kw equals the concentration of H plus times the concentration of OH minus, which equals 1 times 10 to the minus 14 in this case, because we haven't been given a Kw value. The concentration of OH minus equals the concentration of NaOH, because NaOH is a strong base, therefore it's fully dissociated, and that equals 0.140. That means that the concentration of H plus is going to equal Kw over the concentration of OH minus, which equals 1 times 10 to the minus 14 divided by 0.140, and that gives us 7.143 times 10 to the minus 14. If we put that into our pH expression, so pH equals minus log of H plus, or the concentration of H plus, so if you minus log that number, it'll give us 13.15, and that's our answer. So if you want to go back the other way and work out the concentration of an alkali if you're given the pH, you just got to basically work any other direction. So the first thing you can do is calculate the concentration of H plus from the pH. So the concentration of H plus is going to equal 10 to the minus pH. And if you want to understand why that is, then you can watch the strong acids video. Then you're going to put that into kW. So kW equals the concentration of H minus times the concentration of H plus, which generally equals 1 times 10 to the minus 14, but sometimes isn't, and it'll be given to you if it's not. So to work out the concentration of H minus, which will be the concentration of the alkali, so the concentration of alkali will equal the concentration of H minus, which equals kW divided by the concentration of H plus. So here we want to calculate the concentration of NaOH with a pH of 12.6. So the first thing we do is calculate the concentration of H plus. The concentration of H plus is going to equal 10 to the minus 12.6, which equals 2.512 times 10 to the minus 13. Then we use the kW expression, so the ionic product of water, which equals the concentration of H plus times the concentration of H minus, which equals, if not given, 1 times 10 to the minus 14. So the concentration of NaOH will equal the concentration of OH minus, which equals kW divided by the concentration of H plus. So this is kW here, this is the concentration of H plus here, so we just put those two numbers in. So we're going to have 1 times 10 to the minus 14 divided by 2.512 times 10 to the minus 13, and that gives us an answer of 0.0398. Remember to put units, and that's moles per dm cubed. So finally, we need to be able to calculate the pH of water at different temperatures and explain why it's still regarded as being neutral. Now what I mean by that is that at different temperatures the pH of water may not be 7, but it's still neutral, and you need to be able to explain why that is. So you need to remember that water is partially dissociated, and we discussed this at the beginning of this video. It's partially dissociated into H plus and OH minus. Now if we look at our kW expression, that equals the concentration of H plus times the concentration of H minus. If we were to heat water up, then this equilibrium would shift to the right, causing more H plus to be made, which then means that the pH would decrease, because if there's more H plus ions, then it's more acidic. Remember, the pH is based on the concentration of H plus ions. So let's say that we had water at 40 degrees C. If we had water at 40 degrees C, then we could say that maybe the kW value, I'm going to make this up, might be 2.6 times 10 to the minus 13. Remember that the kW value depends on the temperature. At 25 degrees, it's 1 times 10 to the minus 14, but if the temperature changes and the kW value changes, and I'm going to say that it's 2.6 times 10 to the minus 13 here, it might not be, I've just made that number up. But what you might get asked to do is work out the pH of water from the kW value. And what you need to remember is that for every H plus ion that is created when water dissociates, one OH minus ion is created as well. So we can simplify this kW expression to say that kW must equal H plus squared, because the concentration of H plus equals the concentration of OH minus. So using that, we can now work out the pH, because we can say that kW equals H plus squared, so the concentration of H plus will equal the square root of kW, which equals the square root of 2.6 times 10 to the minus 13, which gives us 5.1 times 10 to the minus 7. Now if we put that into our pH expression, so we need to say pH equals minus log of the concentration of H plus, that will give us a pH of 6.29. Now you may get asked, well, why is water still neutral even though its pH is 6.29? And to answer that question in an exam, all you need to do is state that the concentration of H plus ions still equals the concentration of H minus ions, because for a solution to be neutral, there must be the same number of OH minus ions as H plus ions. So all you need to put to answer that question is the following expression: the concentration of H plus equals the concentration of H minus, and that would be enough in an exam.